Okay, so what we're going to look at in this is we're going to look at how to create a scatter plot, draw a linear model, and use a linear model to make predictions. Okay, so if we read the first question, I'll give you a minute to read that, all the way down to part A, and then we'll talk about it together. Now this is where I suggest you pause the video, and then you can press play, and then I'll pick up right where you left off. Okay, and when you look at this section right here, okay, what this is basically saying is that when you look at the CPI of 125.2, okay, what that would mean is that all those goods, services, and housing, whatever year we're looking at, where the CPI was 125.2, whatever year that was would be 25.2% more expensive than that baseline in 1982 to 1984. Okay, so that's how you interpret what these numbers actually mean. Okay, so again, if you need to pause this and read the question again yourself, that's fine. But I'm going to go right to part A, just for the sake of time here. And we want to make a scatter plot on the grid below of T comma C, where T represents the year since 1976, and C represents the CPI. Okay, so when we look at our values, we have the year and the CPI. Well, notice they tell you that the years are since 1976. So when we look at our T values, our time, number of years since 1976, we'd have a T value of 0, 4, 8, 12, and so on. Okay, so you can actually go through and fill all those in. Okay, so when we're asked to make a scatter plot, that means that our independent variable T will start at 0, and we have to fit all the way up through 36 would be the value for 2012. Okay, so if we make our axes going across the bottom, okay, that's our t-axis, and we're going to start 0 years since 1976, and then it looks like a scale of 4 would be a pretty good scale to use. So 4, 8, 12, and so on. Now what I'm going to do here in a minute, I have one already completed that I'm going to switch out here, so you can finish filling those in, okay, going up by 4s. Okay, and then going up the side, we have the CPI values. Well, the smallest CPI up here is 56.9, and it looks like they generally increase. Now maybe not by the same amount each year, but they increase each year through 2012, which is 229.6. Okay, so when you think about a good scale to use for that, okay, if we try a scale of 10 going up the side, okay, you can quickly see that you would run out of room. Okay, so if we had 0, 10, 20, 30, and so on, we wouldn't get to we wouldn't be able to fit 229.6 in there. Okay, so you find what'll work nicely is a scale of 20. So starting with 20, 40, 60, and so on. Okay, and again, you can finish those, because what I'm going to do, again, just for the sake of time, is I'm going to switch this paper out and then have a completed scattergram drawn for you. Okay, so you need to complete the scales on each of the axes, and this will be the C-axis. Okay, and then actually go through and plot the points. Okay, so the first point would have been 0, 56.9. Okay, and because of the scaling, you're going to have to kind of guess where the points are. Okay, so again, you may want to pause the video so you can do this, and I'll switch out the paper. Okay, so this is the scatter plot for the CPI in T years since 1976. Okay, notice I have the axes labeled down here for the t-axis and the CPI on the vertical axis. Okay, we have the points plotted. Okay, so those are in red. Okay, I completed the t values on the side over here. Okay, and then that'll complete part A. Okay, we have the scatter plot. So when I ask you to do a scatter plot, that's all you do. Okay, you scale the axes, plot the points. That is a scatter plot. You don't automatically just try to connect points together. Okay, so the next question in part B, it says, is the data for CPI linear or approximately linear? And explain. Okay, so when you look at taking a straight edge, okay, so I have a trusty piece of cardboard here. Okay, if you look at linear, okay, meaning do the points all fall on the same line? Well, you can see if I were to draw a line through, let's just say, you flip it upside down here, through the second and third points that we have plotted. Okay, you can see that the rest of the points are a little bit below that line. Okay, so we have a line going through 2 points, but it doesn't go through all the other points. So this data is not exactly linear. Okay, so that's how we can tell from looking at the graph. Okay, so not exactly linear, but is it approximately linear? So does it look like those points would follow close to a line? Okay, well, if I draw a line there, that looks pretty close. Okay, so it looks like the points are close to that line. So we would say approximately linear. Okay, and the explanation is that the points are close to a line. Okay, so next part, in part C, what we'll do is we'll draw a linear model for the CPI. Okay, so it's not exactly linear, but we're going to draw a line that will come close to the points. And this is where everybody's scatter plot may be a little bit different. Okay, but I'm going to draw mine. Okay, it looks like a line right around, oops, right around here would be pretty good. Okay, that might be a little bit off. And again, every one's will be a little bit different. Okay, but as you can see, it looks like those data points come close to that line. Okay, yours may be a little more slanted, a little less slanted. Okay, if you drew a line down here, okay, obviously that's wrong. Okay, a line like this, that would be wrong. Okay, so now what we're going to do is we're going to, in part D, we're going to use our model to predict the CPI for various years. We have years 2000 and 2020, and then we're going to write the answers as an ordered pair. Okay, so in the year 2000, we're going to use our model. So the year 2000 is how many years since 1976? Well, we can say 24. So we look at a value of 24. Okay, so when t is 24, we go up until we hit our model. Okay, we don't care where the actual point was, where that red dot is. We're looking at our model, which is just above that red point, or the red dot. Okay, so we have, I would say maybe 175 or so. We can see the actual value here in 2000. Okay, that value was 172. So we're going to be just above that. Okay, so in the year 2000, I would say right around 175. So as an ordered pair, that would be 24, comma 175. For the year 2020, well, how many years since 1976 is that? Okay, that would be 44. So what we do there is we look at 44, and it looks like we'll hit the graph right around here. Okay, so if we go to our C-axis, we have 220, 240, 260, maybe 270. Okay, because this next line up will be 280. So maybe right around 270. Okay, so it looks like 270. So as an ordered pair, that would be 44, comma 270. Okay, so we go to the next page. And it wants us to, in part E, in what year would you predict the CPI to be 200? And write the answer as an ordered pair. So the CPI to be 200, that's going to be on the vertical axis. Okay, and we're going to have to flip back and forth here. So we're going to look for 200 on the vertical axis. And it looks like we hit the line, our model, right about here. So if we go straight down, it looks like we're at maybe 29 or 30. Okay, I'm going to say about 29. Okay, so it looks like the t value is approximately 29, which would be, if we had 29 to 1976, we would get the year 2005. Okay, so it'll be the year 2005. Okay, as an ordered pair, it'd be the year is 29, and then the output, the CPI was 200. So 29, comma 200. Okay, moving on to part F. By computing the ratio of the CPI in two different years, we can determine how much higher prices were. We use the actual values in the table to compute the CPI of 2012 and the CPI of 2000. Okay, so the CPI in 2012, using the actual value, that means the value from our table. So the actual value in 2012 was 229.6. And then we look at the actual value for the year 2000. Yep. And that was 172.2. Okay, so there, if we do that, we're going to take 229.6 divided by 172.2, and we get 1.33 repeating. Okay, and what that tells us is that the typical prices in the year 2012 were 1.33 repeating times higher than in the year 2000. As a percentage, it means that the prices in 2012 were 33.3% higher than in the year 2000. So if something cost you $1 in 2000, you would expect it to cost $1.33 in 2012. Okay, so the next question, if an item cost $40 in the year 2000, use your answer from F to determine how much you would expect the item to cost in 2012. Okay, so again, at this point, if you want to pause the video and try it yourself, you can. Okay, but I'm going to move on. So what you would do is, we know that if we're 1.33 times more expensive or higher in 2012, we're going to take our cost in the year 2000, which was $40, multiply it by 1.33, and that'll give us $53.20. Okay, so that means the item will cost that much in the year 2012. Or we'd expect the item to cost that much. Okay, and then moving along, in part H, it says use your linear model. Whoops. There we go. I guess we'll just look at it. Use your linear model to predict how much higher prices will be in 2020 than 2000. And then if an item costs $15,000 in 2000, then how much would you expect it to cost in 2020? And show your work. There's a typo there. Okay, so we look at the CPI in 2020. This is similar to the last question. Well, the CPI in 2020, when we go back to our table, we don't have the actual value. Okay, and I would hope we wouldn't have the actual value because we haven't hit the year 2020 yet. So if we had that value, we'd be in some kind of time warp, and we'd be in trouble. All right, so what we do is we're going to use our model. The year 2020 was 44 years since 1976. And we already found that down here in part D. Okay, we said the CPI was 270. Okay, so we're going to say the CPI in 2020 was 270, and we'll divide that by the CPI in 2000. Now this one, it's a little bit questionable whether or not we're going to use the model or the actual value. Because we know the actual value in 2000 was 172.2, okay, we'll actually use that. If we didn't know, we'd have to look it up using our table again. I'm sorry, not table, the graph. Okay, but again, we knew the actual value, so we could get that one right from the table. Okay, so when we do that division, we're going to take 270 and divide it by 172.2, and that gives us about 1.57. Okay, if we round it, right around 1.57. Basically saying that in 2020 we'd expect things to be about 57% more expensive than in the year 2000. So there's something to look forward to. Okay, now, have we answered the question yet? Well, we predicted how much higher prices will be in 2020 than 2000, but we have to specifically mention the 15,000. So if something costs $15,000 in the year 2000, we're going to take 15,000 and multiply it by the 1.57. Now the exact value without the rounding, because I had this value in my calculator, okay, and I'll show you here real quick. In my calculator, okay, hopefully you can see that. I kept that decimal in there, okay, the 1.5679. So the exact value, 23,519. But now if I do 15,000 times the rounded value, of 1.57, I forgot the 7 in the page here. Okay, 1.57. We get 23,550. So there's a little bit of a difference there. Okay, so something that costs like a car or whatever that costs $15,000 in the year 2000, we'd expect it to cost about $23,550 in the year 2020. Okay, so that takes care of the example that I'm doing with you. Okay, there's another example that I want you to do. Okay, I give you a table that represents the percentage of a country's population that is foreign born. Okay, and one thing I'll make sure you pay attention to here, you want to do a scattergram of the data where T represents the year since 1950 and P represents the percentage. Okay, so when you look at the table here, notice that we give you 1960 to start with. So when you look at your T values, that first T value is going to be 10. Okay, and then the next one 20 and so on. Okay, so that's going to affect your scaling on the axes. Okay, and just so you don't get too freaked out if you try this on your own. Okay, just so you know, the scale that I used across the bottom axes for the T axes, I said every tick mark was worth 5. Okay, so when you go across the bottom, just to spread the data out a little bit, I said 0, and then 5, 10, 15, 20, and so on. Okay, and then up the side, I just used a scale of 1. Okay, because everything fit in there nicely. Okay, so again, I would ask you to pause the video and try to finish that on your own. And I have one all worked out here that I'll put up in about 5 seconds. Okay, so this is what I have for the scattergram. Now I already drew a line in there. That's just answering part B. The scattergram is just the points. Okay, you'll notice that these points are not too close to a line. They're pretty spread out. Okay, but we can still model the data with a linear model, but it may not be a great linear model. Okay, and that's something that as we go through the course we'll talk about. Okay, but right now we're just going to draw a linear model because I told you to, and then as we go through the course we'll see if there's a better option for that or not for the data. Okay, so we did the scattergram. I drew a linear model, and again, this is one of those that people are going to draw that model in a lot of different places. Okay, so this is one where if you drew the model like this, that wouldn't be wrong. A model like this, that wouldn't be wrong. Okay, so this one, there's a lot of different possibilities right there. That wouldn't be too bad. Okay, so where depending where you draw that line, you could have a lot of different answers. Okay, so now using my line, okay, so what I drew, okay, my blue line, in part C, I'm going to predict the percentage of foreign-born members of the population in 1975 and 2020. Okay, so again, this is using my line. In 1975, it looks like about 5%. Okay, so that was a t-value of 25. Okay, so that was a t-value right here of about 25, and it looks like right around there. So I said 5%. And then 2020, that was a t-value of 70. So that was the point up here, which was about 12%. Okay, so that's where those two answers are coming from. Okay, part D, if the total population was 25.6 million people, then how many would you expect to be foreign-born? Well, 2005 is a t-value of 55. So in 2005, a t-value of 55 gives us about 9.6%. So when you look at a t-value of 55, we're right about here. Okay, so again, it's going to be a little estimating. And again, pay careful attention that this is my line. Your line may give you a slightly different value. But in any event, what you need to do is that once you have that 9.6%, we're taking 9.6% of the total population. So that means you're going to multiply 0.096 times 25,600,000, and you end up with almost 2.5 million. So 2,457,600. Now this will be one that if you said approximately 2.5 million or 2.46 million, that would be acceptable. Okay, because our units here are millions. So if you wanted to write 2.46 million, that will be fine. Okay, but this is without writing million after it. Okay, and then the last question, in what year would you expect 10% of the population to be foreign-born? Well, you look at 10% on our grid. Okay, 10% is up here. Oops, sorry. You go straight across. And this one you have to estimate a little bit. When you go straight down, it looks like we're right around in here. Well, remember, this will be 55. This will be 60. So it looks like right around 57 or 58. Now I said 57 for mine. And again, yours might be a little bit more or less than mine, depending on where your line is. Okay, so don't look at my answers and say, well, gee, I missed it, or you missed it, because it's not matching up with what is written here. Okay, because it all depends on where you drew your line. Okay, so that is it for drawing a scattergram, drawing a linear model, and then making predictions based on that linear model. So thanks for watching.